Hello, my name is Goh Yong Hao, and I'm a designated group leader for Group 8 Electronic Device Circuit Assignment 1. I will represent my group in explaining the simulation of the circuit that we built and designed in Tinkercad. So, as you can see, this is a whole circuit. We can see there has there is three parts that is important. This one the power supply, and this one like this diode is responsible to rectify the AC signal here. And also after this is a filter. This acts as a filter to filter signal with in order you filter the signal to make from the rectified signal to this. Originally, we do not have space for that. We can I can show you this from the before we can connect a load. It's a center tap back here. We remove the diode here because we think it is not necessary for our case as a whole. But we can you can see here it is rectifying the circuit for the positive second only. It's a half rectifier, so this positive signal is is only can pass through. The negative one cannot. Then the negative cycle is flat. I go back. Then it goes through the filter and it will be like this. Also, we should mention that the capacitance value will affect the filter signal. You can see here if the capacitance is too low, then it's almost not filtered. It is gradually if we increase the capacitance, the ripple voltage will decrease until almost flat like this. This scale is not the same with the just like before because the scale is different. But don't worry, it's the same. Then after we filter it, then we need to regulate it at 3 volts using a Zener diode. This is a 3 volt breakdown voltage Zener diode here, and output will be almost smooth 3 volts. In this case, it is 3.07 volts. So that is all for this half wave only, because we do not use a full wave rectifier such as this one because we found that there is a problem. It cannot simulate it. The Tinkercad cannot simulate it. It may work at the front. Yes, the rectifier can work. Then after the filter, after the signal pass through the filter, then the Zener diode, then all of the circuit can crashes. But the software, I can see already started a simulation. The simulation has not started. The screen is lagging. I cannot move the screen. So this is a problem that I think we cannot fix. So we just leave it here. We just start from scratch. We stop it here. We just go with this since at the end of the day, we did the main task that is converting the AC signal here to a 3 volts DC signal. Of course, this is arbitrary. We can set uh, uh, any voltage below the peak voltage of the starting point here. But it doesn't matter because this is we decided to make a 5 volt voltage to a 3 volt voltage. No, not sorry, not a 5 volt to a 10 volt to a 3 volt. But it depends on US. The most important part is the Zener diode here. You set it at 3 volts, so the output will be 3 volts. It can be 4 volts if you set it like this, 4 volts. then it rises a bit, but it is slightly not stable. So because the input, maybe the input voltage is not high enough, so set it back. And it's stable.